I'm Trisha Gupta, registration number 18BEC0832 and serial number 52. I have chosen ESP32 developed by Shanghai-based Espressive Systems as the microcontroller. It was launched in 2016. It is an advanced microcontroller, cost-effective, and one of the few microcontrollers with rare features like DAC, integrated Wi-Fi and Bluetooth, two high-speed computing cores, which is Extensa LX6, and an integrated ISP, image signal processor. This makes it ideal for Internet of Things and digital image processing. Its design is open source and is very robust to use. These are one of the main reasons for me choosing this microcontroller. I will be discussing a few more points about the microcontroller to help its analysis during this presentation. Draw the clear block diagram of the microprocessor or microcontroller or IP core selected. I used Pages software to prepare my document and all the flowcharts. It is a built-in software in MacBook. My content is mainly referred from ESP32 Technical Reference Manual, ESP32 Datasheet, Extensa LXS Customizable DPU. I've also taken help from other sites which are mentioned at the end of the presentation. The ESP32 is a very versatile system on a chip that can be used as a general purpose microcontroller with quite an extensive set of peripherals, including wireless capabilities. The functional block diagram of ESP32 is comprised of embedded flash memory, core and memory, cryptographic hardware acceleration, wireless network hub, and RTC section. Ultra-low power coprocessor in RTC section allows one to do ADC conversions, computation, and level thresholds while in deep sleep. One big advantage to use this ESP32 module is that it has preloaded the low-level device drivers, the wireless protocol stacks for Wi-Fi, Bluetooth and BLE, and free RTOS as the base OS. These are the internal diagrams of each and every block. The key software and hardware to perform debugging of ESP32 with OpenOCD over JTAG interface is presented here and includes Extensa ESP32 debugger, OpenOCD on-chip debugger, and JTAG adapter connected to ESP32 target. Debugging using JTAG provides quick and easy transition from writing, compiling, and loading the code to debugging, back to writing the code, and so on. Inside Terra's complex system on chips, you can find many different processors from general purpose processors to function specific offload engines that add programmability and flexibility. Although general purpose embedded processors can handle most of the control tasks well, they lack the bandwidth needed to perform complex data processing tasks. Extensa LX6 DPUs are configurable and extensible and ideal for handling complex compute, extensive digital signal processing applications, where a register transfer level RTL implementation may be the only other option. Provide the instruction set of the ESP32, memory required, flags affected, and type of instruction based on addressing modes, operation, etc. There are in total 80 instruction sets, which includes ALU, general purpose registers, and special purpose registers. There are three addressing modes mainly: default mode and master mode. To process a message block, 60 to 100 clock cycles are needed, minimum. To calculate final digest, 8 to 20 clock cycles are needed. Explain microprocessing element architecture. The expressive ESP32 is an integrated circuit which is a dual-core microcontroller consisting of two Harvard architecture CPUs, which is namely the Extensa LX6. It has a 4 GB 32-bit address space which is symmetric between the two CPUs. Control unit here is connected to ALU, data memory, input and output,
and instruction memory. Correlate the microprocessing element architecture with architectures discussed in Module 1.
The device which transmits the data receives the data frame in parallel from data bus. The UART device adds a start bit, parity bit, and stop bits to the data frame before the whole data package is sent via UART to the receiving device. The receiving UART device extracts the data frame and forwards the data frame in parallel via data bus. The data path loads new data parameters, that is expected data, read or write data transfer, stream or block transfer, block size, byte count, card type, timeout registers, etc. whenever a data transfer command is not in progress. If the data expected bit is set in the command register, the new command is a data transfer command, and the data path starts one of the following operations: transmitting data if the read or write bit is equal to 1, receiving data if read or write bit is equal to 0.
The flowchart for the same explanation is presented here. Elaborate register organization of microprocessing element.
Each of the two CPUs, Pro CPU and App CPU, in ESP32 has 32 KB of cache for accessing external storage. Pro CPU uses bit Pro cache enable in register dport Pro cache CTRL register to enable the cache, while App CPU uses bit app cache enable in register dport app cache CTRL reg to enable the same function.
Explain the type of algorithm used for signed, unsigned calculations.
The ALU arithmetic and logic unit performs arithmetic and logic operation on values stored in ULP coprocessor registers and on immediate values stored in the instruction itself. Arithmetic includes add and sub, logic includes and or, bit shifting includes LSH and RSH. Moving data to register is move. Stage count register manipulation is stage RST, stage INC, and stage DEC.
The ULP coprocessor also provides instructions to perform arithmetic and logic operations ALU. There is another table over here, operand, with the description. ALU SEL gives type of ALU operation. RDST gives register RZ23, destination. Our source 1 is register R023, source. Our source 2 is register R023, source. Find what type of control logic unit used and correlate its performance with the type of control unit in Module 3 in the COA syllabus.
The command path in the flowchart configures clock parameters, configures card command parameters, sends commands to card bus, receives responses from card bus, sends responses to BIU, drives the P bit on the command line. There are other primary functional blocks also, which are as data path, SDIO, clock control unit, multiplexer and demultiplexer unit.
The command path state machine is given over here. Explain the memory management system in the processing element selected. List its addressing capabilities, memory mapping technique followed. Find the advantages of memory design and management techniques over the concepts given in Module 4 in the COA syllabus.
The address mapping of the two CPUs, that is App CPU and Pro CPU, is symmetric, meaning that they use the same addresses to access the same memory. Multiple peripherals in the system can access embedded memory via DMA.
Address space information, embedded memory information, and external memory.
Addresses below 0x40000000 are serviced using the data bus. Addresses in the range 0x40000000 to 0x4FFFFFF are serviced using the instruction bus. Finally, addresses over and including 0x5000 are shared by the data and instruction bus.
Elaborate the pipeline and parallel processing capabilities of the unit and hazard management technique.
Dual Tensilica LX6 core is used to execute the code. It controls the execution in separate cores by the use of free RTOS and assigns tasks to each CPU. It has high bandwidth data flow through processor with flexible input-output interfaces that are independent of the system bus. Huge bandwidth means more parallelism to reduce cycle counts. Single or double precision scalar floating point options to match the exact application requirements.
Find whether processor level parallelism is available in the element selected. Illustrate cache coherence and protocol used for handling memory hit or miss.
ESP32 uses a two-way set associative cache when the cache function is to be used either by Pro CPU or Wrap CPU. Bit cache mux mode in register, depot cache mux mode reg can be set to select pool 0 or pool 1 in the internal SRAM 0 as the cache memory. When both Pro CPU and App CPU use the cache function, pool 0 and pool 1 in the internal SRAM 0 will be used simultaneously as the cache memory. When bit cache mux mode is set to 1 or 2, Pro CPU and App CPU cannot enable the cache function at the same time. When the cache function is enabled, pool 0 or pool 1 can only be used as the cache memory and cannot be used by the instruction bus as well.
References.
These are the reference links which has helped me to prepare this presentation.
This is the page document which I had used to prepare my flowcharts. I used the shapes and arrows from here. And so on. All my flowcharts were made like this. With this, I complete my presentation.